This example comes out of Math 20, Chapter 7, Section 7.4, Reciprocal Functions, which truly feels like it has nothing to do with the rest of the chapter. This is the type of question we'll be asked to do. So first of all, we might graph just a plain old function like we would have earlier in the course. This one is a parabola. We should be pretty good at that by now. In this case, I decided to factor it so I could see where its zeros were. We have something that looks like this. I've labeled probably a couple more points than I need to, but I've got the x-intercept, the y-intercept, and some other random point there, 4, 6. Now, what we're asked to do in 7.4 is to graph the reciprocal of that, meaning 1 over that function. 1 over, in this case, 1 over x squared minus x minus 6. So question is, how do you do that? Well, the way I would do that is start with the parabola that you had. So the parabola we just drew, I just redrew it. And the most important spots are actually the zeros. Because if you try doing 1 divided by 0 right now on your calculator, 1 divided by 0 gives you a big fat error message. You can't divide by 0. And so what that looks like visually on this graph is these vertical asymptotes. So one of them is at x equals 3 because the original parabola had a 0 at 3, 0. The other one is at x equals negative 2 because the original parabola had a 0 at negative 2, 0. So the original x-intercepts become vertical asymptotes. You'll also notice there's a horizontal asymptote that I should have labeled here at y equals 0. Y equals 0. The graph will approach that infinitely close without ever touching it. Another interesting spot is the fact that when you do 1 divided by 1, you still get 1. Or you do 1 divided by negative 1, you still get negative 1. And so you have what are called invariant points. Had I been looking for them on the original graph, I would have just gone to, where does y equal 1? Oh, well, there'll be a point right there on my green graph, and there'll be a point right here on my green graph, wherever y equals 1, and wherever y equals negative 1, I would have a point there and a point there on the reciprocal graph, and I do. I also would take any other point and do 1 divided by the y-coordinate. So this weird point that I labeled here, 4, 6, becomes 4, 1 over 6. The y-intercept that was 0, negative 6 becomes 0, 1 over negative 6, or negative 1, 6. The overall shape is very strange, but you'll notice as the black graph goes up, the green graph goes down. As the black graph goes down, the green graph goes up. But you don't change signs. In other words, if the black graph is positive, the green graph is positive. If the black graph is negative, the green graph also has to be negative. 0 is most important, most interesting. Those are your non-permissible values. Those are your vertical asymptotes. So there's your two functions right there.